So thanks for coming, everybody. This evening I'm going to take you through the basic fundamentals of using Node-RED. I sometimes get a bit excited and speak very quickly, so if I'm saying unintelligible things, please do let me know and I will slow it down as best I can. But before we get started, can I just get a sense of the room basically? Who here would say they're a software engineer or has experience in programming of some sort? So, okay, cool, about half of you, there it is. And so the rest of you here, because you're curious about Node-RED and you want to see about these sort of things. Okay, wicked, cool. Well, good news, we've got things both groups, so it's good times. So, over the next little while, I'm just going to go through what Node-RED is, what makes a program, how Node-RED differs from more conventional coding methods, and then we're going to get stuck into the meat of the workshop and actually put together some flows. But in order to do that, we're first going to go through the basics of how people have largely made apps in the past, in the present, and the future. And when people think of code, they tend to think of something a bit like this, or maybe even this, or maybe even this. And these are some examples of modern programming languages, and I put the word modern into quotes because most of them are at least 20 years old. And even though they look different, they're all actually achieving the same thing in these examples. They're all doing the Fibonacci sequence. They're just doing it in a different way. When a developer has wanted to create an application at some point in the last 50 odd years, they've probably sat down with a computer, they've probably opened a text editor, and they've used a programming language of their choice that when they've finished it, the computer takes the instructions and converts them into machine code, which is a set of instructions that the processor can run, which is good. But that's not always been the way that people have programmed computers. The very first computer, Charles Babbage's analytical engine, was programmed by punch cards, and the first computer program was written by Ada Lovelace on one of those punch cards. And in fact, we're currently in a company building that has something over here with punch cards. Over a century ago, IBM was originally called the Computing, Tabulating, Recording Company. We were all about punch cards back then. Anyway, and most programming was done on punch cards, like right up until the mid-1970s. In fact, the legacy of punch cards is still with us today. When you release a patch for your code, that's named after you putting a piece of tape over the hole in your program to change what it does. If you were debugging something, you call it a bug because of someone called Rear Admiral Grace Hopper. She was running a program and she couldn't figure out why it wasn't working. So she went to the machine and found a moth in it. She was debugging. We used to use that term today, but I'm getting carried away. As computer programming has applied to the problems of the world, people have been writing more and more complex programs. And it gets hard to track what's going on when your program exists as a bunch of holes on a piece of paper. And so to try and fix this, people started looking at ways to program computers in a more human-defined, relatable, understandable, passable way. And that's how we got programming languages. These are sort of them. The top left there is Golang, the bottom left is, I think, Erlang, top right is Python, and the bottom right is, I want to say Java?
Java.
Yeah. It's Java? Yeah. Anyway, and so as more and more people program this way, more and more languages arose, and you could be given to thinking that writing lines of code was the be-all, end-all of writing programs for a computer. But as we've just seen, it wasn't always this way. And as these programming languages arose, flow-based programming happened alongside them. And that's what Node-RED is. Node-RED is a way of programming with flows. Instead of lines of code, the approach is different, but the result is the same. The developer is still expressing to a machine what they wanted to do, and the computer still takes its instructions and makes it work in a way that it can understand. But what is flow-based programming? Flow-based programming is a graphical way of creating computer programs with flows. Flow is a series of nodes, which are basically just boxes that have an input, an output, or both. Too fast? Okay, cool. And they're all connected to each other. At the start of the flow, some data is entered. That data is then passed from node to node in some way. And each node has a specific job. For the input it gets, it will probably manipulate or analyze it there in some way, and then send it on to the next node in the chain. Depending on the node, it may do the same thing, or it may do something entirely different. So this little abstracted diagram I have here, the white boxes are nodes, the blue boxes are the outputs, and the green boxes are inputs. And they're all connected together with grey wires. So an output can only be connected to an input, but one output can be connected to multiple inputs, and one input can be connected to multiple outputs. The arrow there is to show you that information tends to flow through something. It's not a strict direction, but for node reads, things tend to go from left to right. So if you have a node on the left connected to a node on the right, it means it's probably going that way, but not particularly strictly true. Anyway, let's do an example. Let's say I have an input node which generates random numbers, which is connected to a node whose job is to multiply everything that comes into it by 2. And then that node is connected to another node whose job is to output everything it receives to the screen. When the first node generates a 2, it gets passed on to the second node, where it turns the 2 into a 4, which then passes to the output node and prints the 4 to the screen. If the number randomly generates 50, then the output is 100. If it's 26, then the output is 52, and so on and so forth. But of course, there is no limit to the types of nodes it can be, or the arrangement they can be configured in. If we add a second node in between the multiplied by 2 nodes, which then divides everything by 10, we then have a different result output on the screen as opposed to what we had before. So if again the input node generates a 2, it gets passed to the multiplied by 2 node, which converts the 2 into a 4, but this time the data is going through to the divide by 10 node. So ultimately the output is going to be 0.4. If a 56, it'll be 11.2, because it's been times by 2 to get 112, divided by 10, 11.2. And for 23, just 4.6. But you can do much more than just basic mathematical operations. You can also pass any kind of data to any kind of node to do any kind of operation. For example, you could have a color image be the input, and the little node could be a grayscale converter. So the output's a grayscale image. You could have an audio file go in, and the output would be a text-based string that says what the thing came in the first place. And all of these are possible in Node-RED, by the way. We can cover those this evening if you're interested. And this is a great way to write programs, because we can see where the data is coming from, where it's going, how it's being manipulated, and what's happening along the way. And that's what we're going to be looking at today.